Hello and welcome to a Vicon YouTube tutorial. This video is on integrating the Vicon IMU with Nexus 2.7. The areas that will be covered in this tutorial are installing the Bluetooth dongle, pairing the IMU sensors, connecting the IMU sensors in Nexus 2.7, changing the IMU sensor mode, data collection, reviewing the data, data transfer and data export. To install the dongle, please ensure the dongle is plugged into one of the USB ports of the PC. You will want to plug the Bluetooth dongle in using the range extender and place the extender so that there is an uninterrupted line of sight from the sensor to the dongle. Click Start and open the Device Manager. Once the Device Manager has opened, you will want to select Broadcom Bluetooth 4 USB device. You'll want to right click on this and select Update Driver, and then select Search Automatically for updated drivers. This will search online for drivers, so please ensure you have an internet connection. And then once a driver has been found, it will update this. Select Close, and then you can close the window. The next step is to pair the IMU sensors with Microsoft Windows. Select Start and search for Bluetooth and other devices settings. Once this window is open, you'll need to go to the top where it says Add Bluetooth and other devices and select this. Here, the IMUs that have been switched on will populate the list and you can select the one that you wish to connect. Repeat this process for all the IMUs that you have. Once the IMUs have been selected, they will appear in the Other Devices list. Now the sensor has been paired with the PC, you want to connect it to Nexus. Open Nexus 2.7, and once Nexus is opened, you want to go to the left hand side in the System pane, right click Devices, Add Digital Device, and then Add iMeasureU. This will bring in the iMeasureU device. You'll need to add the sensor number and give it a name. Once the device has been connected, you'll see the green play icon. Repeat this process for all the other sensors that you have. When the IMU sensors are connected to Nexus, they offer three sensor capture modes: 100 Hz, 250 Hz and 500 Hz. The 100 Hz will provide accelerometer, gyroscope and magnetometer data with 9 axes. The 250 Hz will provide accelerometer and gyroscope data with 6 axes. 500 Hz will provide accelerometry data with 3 axes. To change the sensor mode, firstly select the graph view. This will allow you to see the different axes being displayed. You'll then want to go to the Properties section in the bottom left corner and then select the frequency that you wish to run at. You will notice that when you select the frequency, the graphs will update in real time. Capturing IMU data in Nexus is a simple process. It is captured simultaneously with optical data if there are optical data cameras in the system. Before capturing data, you'll need to make sure that your ProEclipse database is in an active session. If you're not, the Start button in the Capture Tools pane will be greyed out. Enter a trial name, description or some notes, and then select Start. Once you are happy with the trial length, select Stop. Upon stopping the trial, the preview data shown in the graph view will be saved in the session folder in an X1D format and will appear in the ProEclipse database as denoted by the purple A icon. You can see that as further trials are captured, these automatically populate the session folder. The data which gets saved straight away in the X1D format is preview data. This is a nice feature which allows for IMU data to be reviewed before transferring the data off the sensor. To do this, you just need to load the trial as you would any other trial and look at the graph view. Sometimes there may be some gaps in the preview data, and this is due to the 50 Hz real-time stream. However, when you transfer the data from the sensor, these gaps will be filled in by the sensor's data. The data on the sensor needs to be transferred. Please connect the sensor to the PC using the micro USB lead. Select the File Transfer button in the Communications pane and then select the IMU icon on the right hand side. This will show the sensors and the trials that can be transferred. Select the trials you wish to transfer and then select the Transfer Files button. This process can take some time. However, once completed, you will see the green Transfer Succeeded text. Now the data has been transferred, this will replace the preview data. Load in a trial, check that you're in the graph view, and then select the IMUs you wish to view the data from. As can be seen here, there are 9 axes of data. As mentioned previously in the video, the IMU sensor data is captured simultaneously with the optical data. This means that the sensor data is perfectly synced with the optical data. If we open up a previous example that we have of table tennis, you can see that the optical data and the IMU data playing alongside one another. Notice that when the player on the right attempts a smash, this is reflected in the IMU sensor data. The last step is to export the data. So in the trial that is currently open, I want to export the data from the sensors. To do this, I go to the Pipeline button in the Tools pane, select the File Export option, export an ASCII, and then check the settings in the properties. So for this one, I want to export all the devices. Once I'm happy with these, I right click and select Run Selected Operation, or I could select the play button. I know the operation was successful because of the green tick and the C icon in ProEclipse. To open the CSV file, click on the C icon and then the .csv file. This will open a Microsoft Excel spreadsheet of the data. In this example, you can see that there is the acceleration components of X, Y, and Z for that IMU 2098. Thank you for watching this video, and I hope that you have found it helpful. If you have any questions about any of your hardware or software, please do not hesitate to contact us.